Welcome to the Virginia Education Center for Asphalt Technology. This is the Asphalt Plant Level 2 class, and in this module we're going to cover the duties of the plant technician as well as an overview of this class itself. My name is Trenton Clark and I'm with the Virginia Asphalt Association. First thing we want everyone to be familiar with is who's the intended audience for this class. So if you look in your manual, you'll see on page P-3, we're talking asphalt plant technicians, lab techs, QA managers on the VDOT side, and on the industry side, we're looking at mixed design technicians and plant technicians. So with the asphalt plant level 1 credential, once you've taken the exam and passed the proficiency, you're allowed to sample and split samples. Passing level 2 and now taking the proficiency and passing it as well moves you on to the actual testing of the mix as well to see if it's within compliance. So here you can see what each person's certification level must be. Again, with the mixed design technician, if you're working for the contractor, you have to be level 1 and level 2 certified. Plant technician or level 2, you have to have that level 1 certification. So these certs build upon themselves. Some other things to keep in mind, Plant 1 and Plant 2, you're taking a written exam. So the written exam covers the material that is in your manual and covered in this course. You need a 70% to pass both level 1 and level 2. And once you pass the level 1, you take a proficiency exam to get your credential. And once you pass level 2, you take a proficiency exam. You can take the written exams back to back, however, you will not be credentialed until you pass the associated proficiencies. So what are we talking about on a project? We got a lot of communication going on. We got various aspects that play together that's vital to a project's organization. Here you can see lots of different documents that may be involved on a project. Now, while you may be a plant technician and not physically on a project, you must be aware of what applies to the mix that you're producing and you're sampling. So you need to know everything from your specifications down to your copied notes. On a project, there's a hierarchy. Hierarchy means what's the lowest priority to highest priority. So you have standard drawings. On the plant side, it doesn't really mean a whole lot to you because these are drawings on how you build things. What does matter are those standard specifications. So what is actually dictated to you through VDOT specs. Typically for a plant, it's on section 211. If you're dealing with SMA, it's in section 248. But if you have specialty materials, it probably is in a special provision. But you have standard specs, so 211 and 248 in your spec book. You have supplemental specifications. What are they? Over time, these standard specifications may become outdated, but we haven't gotten around to printing a new specification book, a road and bridge spec, so we developed supplemental specifications. These will be in your contract documents, or your contract documents may reference them. They could be kept online, but they override and overwrite what's in those standard specs. It may add things, it may delete things, it may change things, but you have supplemental specifications, and you'll see supplemental specifications for section 211 and even for 248. Plans, again, at the plant side, it really doesn't matter very much because this is how the project will be built unless there's something specifically tied to the mixes that you're producing. You have special provisions. Those special provisions are written into the contract as well. It may be something for a particular mix, like an open graded friction course if it's being used, or there might be a special provision for the 4.75. But again, it's not contained back in your standard spec, so it's a special provision. It's a standalone document. And then at the very end, you have copied notes. That's the highest level. What that is maybe there's some revisions made to that special provision. It may apply to a contract, to a district, to a residency. but it'll be written in a copied note that'll also be part of your contract documents. And again, from the plant side, if there's something you need, maybe it has to do with the amount of limestone that can be used in a surface mix. Maybe there's a special project in Bristol where they're looking to use a different percentage. You need to be aware of that as you're doing your mix designs for the mix design technician, but you need to also be aware of that in case it impacts the testing that you're doing in level 2. Maybe it has different volumetric requirements. If there's notes, typically this will be in a minimal plan or in a plant mix schedule. If there's some notes that may change your material specs, it has the same weight as planned, so it'll overwrite your supplementals and your standard specs. But keep in mind, if you're at the plant as a plant level 2 technician, you just need to be aware of when you get test results. Do I go back to the standard specs? Is there a supplemental? Or is there a special provision or a copied note? So just remember, highest priority, lowest priority. So, talk a little bit more about communication because it's vitally important on your project as you're producing material, some of the type of communication that goes on. There's pre-construction conferences. So before the project starts, the VDOT team will call together the contractor team and they'll come together and they'll talk about the project. They'll be talking about the materials. They'll be talking about the mix designs. They'll be making sure everything is approved materials. Pre-construction conferences are a requirement. You see lots of formal meetings where you actually sit down, there's notes taken, but there's a lot of informal meetings and information sharing. So as the day goes on, as the project goes on, things are going back and forth. And then there can be written communication, asking for guidance, asking for clarification. The contractor may send something to the department requesting information to be provided so the contract can go on. And if it's related to the mix, you need to know what that may be. So overview of what we're doing, but let's talk about what does that plant level 2 technician do. If you've gone through this process, taken the class, you've passed the exam, you passed the proficiency, what does a level 2 technician do? Well, depends on who you work for. If you're working for VDOT, a lot of different duties need this certification, need this credential. You could be observing the mix, collection of samples at the plant. That's why you need, because you need to be able to see what's happening. Is it being done properly? All the way from the back of the truck. Lab testing for verification and independent assurance. You're going to take material, if you work on the department side, or a consultant to the department may be doing testing, and you have to know how to test that mix properly. So you need to be credentialed. And then the old standby with the department, other work as assigned by the employee work profile. So you may be in a position that doesn't directly need, but it could be that you need to have this level 2 technician to do other parts of your job. So on the VDOT side, if you're a consultant, depends who the client is. If you're working for VDOT, you're doing these things. Watching the material being collected, sampled, tested, doing the testing. If you're the contractor, you need to know how to do the sampling, to do the collection and do the testing. So it depends on which hat you're wearing, why you need the level 2, but it goes down to making sure you can test the material properly or look at the test results and make sure that they're correct. So let's look at the contractor. If you look in VDOT supplemental section, specification section 200.06, it says an asphalt plant level 2 technician. An asphalt plant level 2 technician samples the materials, which is the same as level 1, and is capable of conducting any tests necessary to put the plant into operation. Those are tests, your volumetric test, your AC content, your gradation. So not only can you pull a sample, quarter it down, you can take it in the lab, you can test it to see does that material that went through the plant meet specifications to be shipping to projects. What does putting the plant in operation mean? Long paragraph out of section 211.05. The one thing I do want to draw your attention to that separates that plant level 2 technician from that mixed design technician is this very last sentence. The mixed design technician shall be responsible for producing a mixture that complies with the requirements of these specifications. Level 2 does the testing. They can put a plant in operation. But the mixed design technician is one that makes sure that it's correct. The mix is designed properly, as well as making any type of plant adjustments comes from that mixed design technician. So keep those things separated in your mind. Level 2 can pull the mix. They can sample and split it down, run AC content, gradation, volumetrics, put the plant into operation. But as far as the approved mixed design, adjusting the plant, those things comes from the mixed design technician. So, what test do we perform? For a level 2, what do you perform? AC content. How much liquid is actually in the mix? Gradation. So the aggregate that's used in that mix, is it properly graded as it conforms and complies with the mix design? We have RICE testing, or the maximum specific gravity, that GMM. What is the gravity of that asphalt with no air in it? 100%, it's voidless. Volumetrics. We'll get more into the volumetrics and what they all mean, but again, it's another set of properties that tells you you have the right amount of air, too much, the fines, things of that, voids. Moisture in the mix. When we're producing this asphalt, we don't want to have trapped moisture from the rock being then trapped into the asphalt. It could lead to stability problems, could lead to stripping issues. So we need to check the moisture, pull a sample, put it in the oven, let it dry out, see how much weight is lost because of moisture, and there's a spec that says what is the maximum amount, and we compare it to that. And then we do TSR. So like we see in this pill, we put a weight on it, we fracture it, and that determines if through a series of freeze and thaws, water bath, when we test it, what's the retained strength? What's the tensile strength? So we're trying to replicate what may happen out in the field that could cause stripping, could cause loss of stability and failure. So we run all these tests, and during mix design, we also do permeability testing. Mix design, as a plant level 2, you may be assisting, but this is still the responsibility of the mix design technician to sign off. Tensile strength, you may do the testing, but again, this is the responsibility of the mix designer to sign off on it. But during plant running, you're doing these top 5. So let's talk AC content and gradation. AC content of the mix, we use an ignition oven. So we stick it in an oven, we heat it up to 1,000 degrees, and then we weigh the mix at the beginning and then at the end. And that determines, it's assumed what's burned off is liquid asphalt, and what's retained is aggregate. We know that some of the material that goes up through the draft in the exhaust vent will be fines, but for the most part, we know that there's an offset, and we know here's our asphalt content, here's our correction factor, and we'll walk through that in another module. But that's following VTM 102, and all that is in your supplemental documents. Gradation, we take that aggregate, so during the mix design, the mix designer is taking different aggregate sources, blending them together, and making the mix design. So how much 3/8 inch material, how much number 4, number 8, number 30, number 200. When we're into production now, and we've burned off that asphalt, what's left behind is the aggregate in the ignition oven. So we follow AASHTO T30, a wash sieve analysis, and we determine what the gradation is, and we compare that after it went through the plant back to what it was at time of mix design to see if it complies. Rice testing, or maximum theoretical gravity, there we're determining the maximum gravity of the material. I had no air voids. So if you mixed all the rock and all the asphalt together and you put it in an environment where there's absolutely no air in it, what does it weigh? Think of it as that way. What's the gravity of it? We divide it by 62.4, but what's the gravity? Voidless, no air in it. That's following AASHTO T209, and the reason we need to know that is because we compare it back to our volumetrics. We use this value, this rice, to compare it to our volumetrics, but also those technicians in the field that are doing the density testing, they need to know what the rice is because they're cutting cores out in the field, and they need to compare that back to this maximum gravity to see if the compactive efforts in the field with that mix met the minimum spec requirements. So that's maximum, and we'll walk through that in another module. Volumetrics, really, it's a combined term in our specs where we're really looking at the voids as well as the fines to asphalt ratio. And this is the effective asphalt, so it's not the total asphalt in the mix. It's actually a smaller value because the effective asphalt basically accounts for that asphalt that is absorbed into the pore space of the aggregate that really doesn't use for binding purposes. So it may burn off until you got 5.6, but effectively you've got a value less than 5.6 because some of it was absorbed. And that's determined through the mix design for that aggregate, what's the effectiveness of the absorbed asphalt. But we determine what's the voids in our total mix, voids filled with asphalt, voids in mineral aggregate. Our FA ratio, we're following AASHTO R35 as well as AASHTO T166 and T269. All that material is contained in your supplemental package. We talked about moisture a few minutes ago and why it's bad to have trapped moisture in the mix. So we got to make sure that aggregate's dry, and by VDOT spec, it's got to be less than or equal to 1%. So if we get more than 1% trapped moisture, maybe the aggregate didn't get dry during the drying process, maybe there's a lot of trapped water in the aggregate and we didn't slow down, but whatever it may be, we have water that's in there, we coat it with asphalt, it's going to want to try to escape. By spec, if it's more than 1%, it could lead to stripping and stability issues. So if we find that we're failing that 1% criteria, something has to be done, probably slowing down the plant so we get more effective drying during the process. The TSR, why we do it? Because we want to make sure that the asphalt doesn't strip off the aggregate, or basically the aggregate and the asphalt come apart. The asphalt doesn't stick to it. Has to do a lot of times with the charge, but you can get some stripping if you got moisture stuck in there. But we go through that process. We're following AASHTO T283, and VDOT specs is a minimum of 80%. And again, walks through in T283 how that process is performed. And then permeability, what we want to make sure of in this process, and it's done early on, and it's only checked during mix design, is that we want to make sure that when we get the density in the lab and we do a lab test, that water doesn't flow through it. So we do it at 7.5% air voids. That's the minimum for surface mixes per VDOT spec, is 7.5% in-place air voids or 92.5% density. So we do it at that threshold, which is the bottom, and if it doesn't cause water is not allowed to permeate through, then we've got a mix that's determined to be impermeable, so it should have better life out in the field. But why do we go through all this? Why is the certification required? Why can't somebody just get some OJT and go do the testing? Well, federal law. So federal law plays into all this because contractors' test results are used for payment purposes. So since contractors' test results are used for payment purposes, the Code of Federal Regulations says the transportation agency, in this case VDOT, has to have a quality assurance program. And that quality assurance program involves quality control, controls acceptance, controls or includes verification, includes independent checks. Contractor's part of it, because not only are they doing the QC, but they're doing the acceptance side. And even if VDOT was doing all the acceptance, there's some processes they would have to still have in place to make sure that they're testing properly and to make sure that their results are correct. So that's why we go through this whole thing. When we talk about quality control and acceptance, what are we talking about? AC content and gradation. That's what payment is based on. What is your asphalt content? What is your gradation? How does it comply with spec? We test it every 500 tons. But it's randomly. So it's not at ton 500, ton 1,000, ton 1,500, ton 2,000. It's between 0 and 500 tons, we have to do one test. And between 501 tons and 1,000 tons, we have to do another test. It's randomly selected. Those results are used for payment purposes. So how well do you compare with what was the approved job mix formula? We also look at temperature at the plant. That's another acceptance criteria. So we do the first load. So that first load that's dropped out of the silo for this mix that's going to this project, we test the temperature. Is it within spec? Then we test that fifth load. So now the first truck went under the silo, we tested it. Fifth truck comes through, we test the temperature again to make sure it's not too hot or too cold. Typically at the plant, what you're looking for is too hot a temperature, whereas in the field, you're looking at making sure you met the minimum temperature. After the first and the fifth, then it's at least 1 hour or every hour per mix. So again, you're keeping a running check, and a lot of times it may correspond to when you're doing sampling, but not necessarily because it depends on the production. Maximum temperature is 350 for A mixes and D mixes, but if it's an E mix that has polymers in it or some other specialized additive, specialized binders, that's set by the manufacturer. It could be 340 degrees, it could be 360 degrees, but that sets it because you don't want to destroy the binder that's being paid extra for. What are our process controls in our monitoring tests? So if we're using AC content and gradation for payment, how else are we controlling this mix? So we're using volumetrics. So that's our voids, total mix. Voids filled with asphalt. Voids and mineral aggregate. FA ratio, rice value. And there, we typically do randomly in that every 1,000 tons, at least once per day, once you exceed 300 tons of mix. So you may only do 500 tons of mix today. So yeah, you're saying I'm less than 1,000, but if all you're doing is 500 tons of that mix today, you should be pulling a volumetric sample to check it. And it's a pass-fail criteria. Is my VTM for our super paved mixes, our dense graded mixes, is 2 to 5%. Am I less than 2? Am I greater than 5? And if so, do I need to stop production? Could be at 1.9. You can see that maybe the asphalt content was high. You make some adjustments. It brings everything back in. But if you test and it's like 0.06, you may have major issues and you need to stop production. But again, that needs to be worked out at the plant, having a plan of action through your quality control plan and communications with the project, with the VDOT personnel. Independent assurance is making sure that the people, the procedures, and the equipment are functioning properly. This isn't a pass-fail on the material. This is basically a check on everything that goes into checking the material. So are the people certified? Are they following the right process? Is the equipment calibrated? The IA process is in the Manual of Instructions, Section 50206B1. It's performed on AC content, gradation, and temperatures. What does that mean? At times, VDOT will come in, they'll pull half a sample, so the contractor's sampling for their acceptance. They pull a sample, it's big enough that they split it with VDOT. VDOT takes that material back to their lab. Maybe a consultant takes it back to their lab, and they determine AC content and gradation, and they also do an independent temperature check at that plant. So that is part of the IA program. And it's basically performed on every other lot of material. So again, it's a check just to make sure all this is properly functioning. We also have verification, sampling, and testing. That's conducted on volumetric samples and at times an absent recovery, which checks the binder. But just as we're doing with independent assurance, VDOT may show up, they need what they'll call an IA, a verification sample. A bigger sample is taken, maybe split, goes back to VDOT's lab, and they do volumetrics, VTM, VMA, VFA, FA, and GMM as a comparison to does that material meet spec. And VDOT's rep completes what's called a TL10. It's just a form that is traceable from the asphalt plant where it's taken from all the way back to the lab for reporting purposes. At times, not everything checks out, not everything balances out, so we go into a referee system. Section 211.010 of the VDOT Supplemental Specification covers this referee. We're using it when the results are questionable or disputed. So maybe we're thinking about putting a plant in shutdown, limited production, something of that measure. Maybe the results aren't consistent. The contractor can go into and request a referee system, and it may very well mean we need to go out, pull some samples out of the field. Those samples are then taken to a VDOT lab or an AMRL, AASHTO accredited lab, and checked. Payments based on, at the end, tons. So we adjust it, can be adjusted based on AC content gradation. So if the AC content is too high or too low outside of specified tolerances, it can result in a pay adjustment. Same with gradations. Also keep in mind, weigh tickets come out with all loads, whether they're electronic or paper copies. At the end of the day, a TL 102 is filled out by the plant, by the bonded weigh person. Typically we'll get help from the level 2 technician to fill it out, how many tons were shipped to a project. And that determines when pay is calculated. So there we got an overview of the class. We also have an overview of what that plant level 2 technician will do. So when you pass this exam and you pass your proficiency test that's done in the lab, that's what's expected with you. So if you have any questions, ask your facilitator or your moderator. There are some knowledge checks in your book. Take some time, work through them, and good luck.